Okay, someone just asked me a question by email that I thought I could answer with a quick video. So the question was, if you don't want to use the t-distribution app on your phone, how could you do a t-distribution hypothesis test? And so I'll walk through the solution. You can use the table. The t-distribution table actually lets you do both confidence intervals with these different confidence levels and also testing a hypothesis. So let me leave this open, and then let me open it in a new tab, and then I'll also take a look at one of the problems from the review test. So let's go over here to this, and then here. And so on the practice exam, we had one problem. I posted solutions to the problem. So here was the problem. The problem was a hypothesis test question. I gotta scroll down and find it. Here it was. Okay, so we had this hypothesis test about police officers and whether or not they were exposed to higher levels of lead pollution than other people. And so we got a t-value that we calculated was 17.1. And so the next question is, so how do you calculate the p-value? And so I recommend using the probability distributions app for sure. It's the easiest way to do it. But if you want to use the table, here's how you do that. First of all, you have to figure out how many degrees of freedom you have. And in this example, we had 52 police officers, so there's 51 degrees of freedom. So go over to the table, you find your 51 degrees of freedom, and now you'll notice 51 is not one of the options on the table, but the closest number below is 50, so that's what we're going to use. And then you look at the table, and you pretty much ignore the top of the table. This doesn't matter because we're not doing a confidence interval, we're doing a hypothesis test. So we look at the table, and what we're going to actually focus on is the row for our degrees of freedom. So that's this row, which I can highlight. There we go. So we're going to focus on that row, and we're going to look for our t-value. And if it's in there, then great. We'll know exactly what the p-value is. Just look down. Now, typically what happens is you're not going to get one of these numbers exactly. You're going to be between two of them. And then you just look down at the bottom, and that means you're going to be between the corresponding p-values. So I think we were doing a one-sided hypothesis test here because we knew that police officers were in an urban environment, which would increase their exposure to pollution. And so we had prior reason to think that it was going to go one way. So a one-sided p-value is appropriate. So where is our t-value? Well, if it was 17.1, it's off the charts, right? It's past the last number on the chart, which means that we're going to be more significant than anything on this chart. So our p-value is going to be even lower than the last number on the chart. So whatever the last number is, our p-value is lower than that, which means that our evidence is stronger, which means that we can pretty much conclude that this is not a random fluke. This is real evidence that police officers get exposed to more lead pollution than people who aren't in an urban environment. Okay, that's it. That's how you use the table. You just look at your number of degrees of freedom. So you look in that row for your t-value. Then between those 2 points, that's the corresponding p-value, and that tells you whether it's significant or not. Okay. Remember, things don't even start to be significant until you get around 5%. And the further to the right on the table you are, the more significant your results are. Okay. Hope that answered your question. And let me know if this didn't make any sense. I'll be happy to go over it again.